Top 25 Site Reliability Engineer Interview Questions and Answers. Site Reliability Engineering, SRE, combines software engineering and systems operations to build scalable, reliable, and efficient systems. Organizations rely on SREs to ensure high availability, performance, and resilience of critical services. Interviews for SRE roles focus on technical depth, problem-solving ability, automation mindset, and collaboration skills. Preparing structured, thoughtful answers helps demonstrate both engineering expertise and operational awareness. Below are the top 25 Site Reliability Engineer Interview Questions and Answers, designed to help you confidently explain concepts, real-world practices, and your approach to maintaining reliable production systems. 1. What is Site Reliability Engineering, SRE? Site reliability engineering is a discipline that applies software engineering principles to infrastructure and operations problems. The goal of SRE is to build reliable, scalable systems while minimizing manual work through automation. SREs focus on availability, latency, performance, efficiency, and incident response. By using metrics like SLIs, SLOs, and error budgets, SREs balance innovation and stability. This approach ensures systems remain resilient while allowing teams to release changes quickly and safely. 2. How is SRE different from traditional DevOps? SRE and DevOps share similar goals, but SRE provides a more structured, engineering-driven approach. DevOps emphasizes cultural collaboration between development and operations, while SRE defines concrete practices, metrics, and reliability targets. SRE uses error budgets to manage risk and prioritize work, ensuring reliability is measurable and enforceable. Traditional DevOps can be more flexible, whereas SRE formalizes reliability as a feature, treating operations problems as engineering challenges that can be solved with code. 3. What are SLIs, SLOs, and SLAs? SLIs, service level indicators, are quantitative measurements of system performance, such as latency or error rates. SLOs, service level objectives, define target values or acceptable ranges for those indicators. SLAs, service level agreements, are customer-facing commitments with potential penalties if breached. Together, they help teams define, measure, and maintain reliability. SREs primarily focus on SLIs and SLOs to guide engineering decisions, while SLAs are often managed at a business or contractual level. 4. What is an error budget? An error budget represents the acceptable amount of unreliability a system can have within a defined period. It is calculated based on the difference between 100% reliability and the SLO target. Error budgets help balance innovation and stability by allowing teams to release changes as long as reliability stays within limits. If the error budget is exhausted, teams pause risky changes and focus on reliability improvements. This data-driven approach removes subjective decision-making around system stability. 5. How do you design systems for high availability? High availability is achieved through redundancy, fault tolerance, and automated recovery. I design systems with multiple instances across availability zones, use load balancers, and avoid single points of failure. Health checks, failover mechanisms, and graceful degradation are essential. I also implement monitoring and alerting to detect issues early. Designing stateless services and reliable data replication ensures systems can continue operating even when individual components fail unexpectedly. 6. What monitoring tools have you used? I have experience using monitoring tools such as Prometheus, Grafana, Datadog, Nagios, and CloudWatch. These tools help track system metrics, visualize trends, and trigger alerts. I focus on monitoring golden signals like latency, traffic, errors, and saturation. Effective monitoring provides actionable insights rather than noise. By designing meaningful dashboards and alert thresholds, I ensure issues are detected early and engineers can respond quickly before users are significantly impacted. 7. How do you handle on-call responsibilities? On-call responsibilities require preparation, calmness, and strong documentation. I ensure alerts are meaningful and actionable to avoid fatigue. During incidents, I follow runbooks, communicate clearly with stakeholders, and focus on restoring service quickly. After resolution, I participate in postmortems to identify root causes and prevent recurrence. I believe a healthy on-call culture includes fair rotations, automation, and continuous improvements to reduce unnecessary alerts and improve system reliability. 8. What is a postmortem and why is it important? A postmortem is a structured analysis conducted after an incident to understand what happened, why it happened, and how to prevent it in the future. SRE postmortems are blameless, focusing on systems and processes rather than individuals. They help teams learn from failures, improve reliability, and strengthen operational practices. Well-documented postmortems create institutional knowledge and drive long-term improvements, reducing the likelihood and impact of similar incidents. 9. How do you approach incident management? Incident management begins with quick detection and clear communication. I prioritize restoring service over identifying root causes during an active incident. I follow predefined escalation paths and assign clear roles to responders. Once the system is stable, I analyze logs, metrics, and timelines to understand the issue. Afterward, I contribute to postmortems and corrective actions. This structured approach minimizes downtime while ensuring long-term reliability improvements. 10. What is capacity planning? Capacity planning ensures systems can handle current and future workloads without degradation. It involves analyzing historical usage, growth trends, and traffic patterns. I use metrics like CPU, memory, storage, and request rates to forecast demand. By planning capacity proactively, teams avoid outages caused by resource exhaustion. Capacity planning also helps optimize costs by preventing overprovisioning while maintaining enough headroom to handle traffic spikes and unexpected demand. 11. How do you ensure system scalability? Scalability is achieved by designing systems that can grow horizontally and vertically. I favor horizontal scaling using stateless services, load balancers, and auto-scaling groups. Caching, asynchronous processing, and database sharding also improve scalability. I test scalability through load and stress testing to identify bottlenecks early. Ensuring scalability allows systems to handle growth smoothly without performance degradation or reliability issues during peak usage. 12. What role does automation play in SRE? Automation is central to SRE because it reduces manual work and human error. I automate deployments, infrastructure provisioning, monitoring, and incident responses wherever possible. Tools like Terraform, Ansible, and CI/CD pipelines enable consistent, repeatable processes. Automation allows SREs to focus on higher-value engineering work rather than repetitive tasks. By treating infrastructure and operations as code, reliability and scalability improve significantly across environments. 13. How do you manage configuration changes safely? I manage configuration changes using version control, code reviews, and automated testing. Changes are deployed gradually using techniques like canary releases or feature flags. Rollback mechanisms are always in place in case issues arise. I avoid making changes directly in production without proper validation. This disciplined approach minimizes risk, ensures traceability, and allows teams to identify and revert problematic changes quickly without affecting overall system stability. 14. What is the difference between availability and reliability? Availability measures the percentage of time a system is operational and accessible, while reliability measures how consistently the system performs without failure over time. A system can be highly available but unreliable if it frequently fails and recovers quickly. SRE focuses on both aspects by reducing failures and improving recovery mechanisms. Understanding the distinction helps teams design systems that not only stay online but also provide consistent, predictable performance. 15. How do you reduce alert fatigue? Reducing alert fatigue requires designing alerts that are actionable and meaningful. I avoid alerting on symptoms that don't require immediate action. Alerts should indicate real user impact and include context for troubleshooting. I regularly review alerts, remove noisy ones, and adjust thresholds. Using dashboards for observation instead of alerts helps reduce unnecessary interruptions. A well-tuned alerting system improves response quality and prevents burnout among on-call engineers. 16. What experience do you have with cloud platforms? I have experience working with cloud platforms such as AWS, GCP, and Azure. I've managed compute, storage, networking, and managed services like databases and Kubernetes. Cloud platforms enable scalability, automation, and resilience when designed properly. I use infrastructure as code to manage cloud resources consistently. Understanding cloud-native patterns helps optimize cost, improve reliability, and design systems that take full advantage of managed services and global infrastructure. 17. How do you approach disaster recovery planning? Disaster recovery planning involves preparing for worst-case scenarios such as data loss or regional outages. I design backup strategies, replication mechanisms, and recovery procedures with defined RTOs and RPOs. Regular testing of disaster recovery plans ensures readiness. Automation plays a key role in enabling fast recovery. By planning and testing proactively, teams can restore services quickly and minimize business impact during major incidents or failures. 18. What is chaos engineering? Chaos engineering involves intentionally introducing failures into systems to test their resilience. The goal is to identify weaknesses before real incidents occur. By simulating outages, latency, or resource exhaustion, teams gain confidence in system behavior under stress. Chaos engineering helps validate assumptions, improve recovery processes, and strengthen reliability. It aligns well with SRE principles by proactively addressing failure scenarios rather than reacting to unexpected production incidents. 19. How do you ensure security in SRE practices? Security is integrated into every stage of SRE work. I follow the principle of least privilege, secure configuration management, and regular patching. Monitoring includes security-related metrics and alerts. Automation ensures consistent security controls across environments. I collaborate closely with security teams to address vulnerabilities and compliance requirements. Reliable systems must also be secure, and embedding security into operational processes reduces risk while maintaining system availability. 20. What is the role of documentation in SRE? Documentation is critical for operational consistency and knowledge sharing. I create and maintain runbooks, incident response guides, and architectural diagrams. Good documentation helps on-call engineers respond quickly during incidents and reduces dependency on individuals. It also supports onboarding and long-term maintenance. In SRE, documentation is treated as a living artifact that evolves with the system, ensuring reliability practices remain clear and accessible. 21. How do you handle performance optimization? Performance optimization starts with measuring key metrics and identifying bottlenecks. I analyze latency, throughput, and resource utilization using monitoring tools and profiling techniques. Optimization may involve caching, query tuning, concurrency improvements, or architectural changes. I validate improvements through benchmarking and load testing. Performance optimization is an ongoing process that balances user experience, cost efficiency, and system reliability without introducing unnecessary complexity. 22. What experience do you have with Kubernetes? I have experience deploying and managing applications on Kubernetes, including configuring pods, services, deployments, and ingress controllers. Kubernetes improves scalability and resilience when configured correctly. I focus on resource limits, health checks, and rolling updates to ensure stability. Monitoring Kubernetes clusters and understanding failure modes is essential. Using Kubernetes effectively requires automation, observability, and careful configuration to avoid introducing unnecessary operational complexity. 23. How do you balance reliability and feature delivery? Balancing reliability and feature delivery is achieved through error budgets and data-driven decisions. As long as reliability remains within SLO targets, teams can safely release new features. When reliability degrades, focus shifts to stabilization. This approach removes subjective debates and aligns teams around shared goals. SRE enables fast innovation while protecting user experience, ensuring neither speed nor stability is sacrificed unnecessarily. 24. How do you approach root cause analysis? Root cause analysis involves understanding not just what failed, but why the system allowed it to fail. I analyze timelines, logs, metrics, and contributing factors. The goal is to identify systemic weaknesses rather than individual mistakes. Findings are documented in postmortems with clear action items. This approach leads to meaningful improvements, prevents recurrence, and strengthens system design and operational processes over time. 25. Why do you want to work as an SRE? I enjoy solving complex problems at the intersection of software and systems. SRE allows me to apply engineering principles to improve reliability, scalability, and efficiency. I'm motivated by building resilient systems that users can depend on. The focus on automation, measurement, and continuous improvement aligns with my mindset. Working as an SRE gives me the opportunity to make a tangible impact on system stability and user experience. Site reliability engineer interviews evaluate technical expertise, operational judgment, and problem-solving mindset. Strong candidates demonstrate an understanding of reliability principles, automation, monitoring, and incident management. Preparing thoughtful, experience-based answers helps showcase your ability to build and maintain resilient systems. By emphasizing data-driven decisions, collaboration, and continuous improvement, you can clearly communicate your value as an SRE and position yourself as a reliable engineer capable of supporting large-scale, mission-critical systems.